Hi, in this video, we will learn how to use law of cosine to solve triangles. Okay. Then we will try to use both law of sine and cosine to solve some of the problem. Okay. Then let us start. So let's see. The law of cosine is actually talk about if we have the sine A and the angle A, okay, and then B and C is actually adjacent to the angle A. Okay, so let's see how we relate them together now. The law of cosine said that A squared is equal to B squared plus C squared minus 2BC cosine of A. Okay. Okay. If I want to use, again, the angle B and the side B, okay, then now it will be B squared equal to A squared plus C squared minus 2AC cosine of B. Okay. Then now, how about if I'm using the angle C, okay, and the side C, the opposite of C, okay? And again, the A and B, they are adjacent to the angle C, okay? Then in this case, it will be C squared equal to A squared plus B squared minus 2AB cosine of C, okay? Then now, let's see how we prove the law of cosine, okay? So the one that I'm going to prove is A squared equal to B squared plus C squared minus 2 times BC cosine of A. Okay, so this is the one that I would like to prove that. Okay, so we start with these triangles here. I would like to add the H here, which is the height of the triangle. Okay, then I'm going to redraw the triangles to two right triangles. So this is H right here. This is B. This is the angle A. Okay. So another triangle. It is H here, and then we have A. Then now I would like to introduce another variable X right here, which is the length from here to here. Or if you see that this is X right here. So if this is X, of course, this length right here, it will be C minus X. Then now let's see how we relate them together. Okay. To the left triangles, we could use Pythagorean theorems to help us to relate X, H, and B. So we have H squared plus X squared equal to B squared. To these triangles, we have H squared plus C minus X to the square equal to A squared. And now they both have H squared. Then why don't we solve for H squared? So I have H squared is equal to B squared minus X squared. And to this one will be H squared equal to A squared minus C minus X to the square. Okay. Okay. They both equal to H squared. So in this case, we could set B squared minus X squared equal to A squared minus C minus X to the square. So C minus X to the square is C squared minus 2CX plus X squared. So I have A squared minus C squared plus 2cx minus x squared. And you will see that this negative x squared and this negative x squared, okay, we could cancel it, right? And now I would like to move these two terms from the right to the left. So I will have b squared plus c squared minus 2cx is equal to a squared. Okay. Then now I need to take care of this x now. Then go back to this triangle here. Okay. We find that cosine of A equal to adjacent over hypotenuse. Or x equal to b times cosine of A. Right? Okay. And now let us go back to this. Okay. I start with a squared equal to b squared plus c squared minus 2 times c, and then x equal to b times cosine of A. Then we will have a squared equal to b squared plus c squared minus 2bc cosine of A. Okay. Which is what I want to solve it here. Okay. Ooh. And then now, the law of cosine is useful to solve the triangle like SAS or SSS. Okay. So again, law of sine is not working because again, remember law of sine, we need a sine and the angle, okay, or angle to and the opposite side, right, to work it out. However, SAS and SSS do not have that. Okay. Then let's see how we use the law of cosine to help us to again work it out. Number 4 here. So I would like to solve for x, and then we find out that x is opposite to this angle A, which is 180 degree. Okay. And then the 15 and the 18, they are adjacent to 108 degree. Okay. Just like the example that we have here, consider that this angle A is 108 degree. Then B and C basically is adjacent to the angle 108 degree. So this one could be 15, this one could be 18, right? And then the A square is the position of x. So therefore we will have x squared like this. Okay. So then now we have x squared equal to 15 square plus 18 square minus 2 times 15 times 18 cosine of 108 degree. Okay. Then we can use calculator to help us to solve this. So x equal to square root of 15 square plus 18 square minus 2 times 15 times 18 cosine of 108 degree. Okay. Remember to your calculator, make sure that you set the mole to degree mole. Then you should get x equal to 26.7557 then. Okay, that's it. So now let us try to work it out. Another example. What if I have SSS? How do I solve the triangles? Okay. And I also need to find the area of the triangle as well. Okay, so let's see. So I have A equal to 5, meaning corresponding to this angle will be the angle A. Then this is B 6 right here. then this angle will be the angle B. And then if this is 8, meaning this angle right here is the angle C. Okay. So then in this case, we need to work it out again. In this case, we could use the law of cosine to help us to solve one of the angle A, B, or C. Okay. Now to me, I would like to start with the longest side. So meaning I would like to find the angle C first. Now the reason that we do this, because the angle C is the biggest angle that we have. So then after we have this, then we could use law of sine to help us to solve the angle A and the angle B. Okay, something like this. And because we work with the biggest angle, so then when we use the law of sine, okay, it is actually safe that we don't need to have, we will not end up with this situation then, okay, that we have two triangles to work with when we try to work with the law of sine. Okay. Let's see, how do we actually, again, set it up the problem now. So I will have x squared equal to 5 squared plus 6 squared minus 2 times 5 times 6 cosine of C. Okay, then I would like to solve for cosine of C. Then I have x squared minus 5 squared minus 6 squared equal to negative 2 times 5 times 6 times cosine of C. Then I will divide both sides by negative 2 times 5 times 6. Okay. And of course, the angle C is the cosine inverse of x squared minus 5 squared minus 6 squared over negative 2 times 5 times 6 then. Okay, so now then let us bring it up our calculator. Okay, so first, again, remember, check the mode to see if it is in degree mode. Okay, then now we could work this out is the cosine inverse. Okay, then I would like to calculate the x squared minus 5 squared minus 6 squared. Okay, I close it. And then we would like to divide. Again, I will have negative 2 times 5 times 6. Okay, and then we close it. Okay. And then you will find out that the angle that we have is 92.8660 degree then. Okay. Then now, after we get this angle C, then we will be able to use, again, law of sine to help us to find the angle A or the angle B, right? Or I would like to use the law of cosine again, okay, because we need to practice, right? Okay. So now, if I want to use the law of cosine to help me to find the angle A, then we could do that. So I will have the opposite of A is 5. So I start with 5 squared is equal to 6 squared plus 8 squared minus 2 times 6 times 8 cosine of A. Okay. So now I would like to solve for cosine of A. Okay, so then I have cosine of A is equal to 5 squared minus 6 squared minus 8 squared divided by -2 times 6 times 8. And the angle A is the cosine inverse of these expressions. And my calculator tell me that it will be 38.6248. Okay, so once we have the angle C and the angle A, then of course we will be able to find the angle B is equal to 180 minus 92.8660 minus 38.6248. Okay. Then it is equal to 48.5092. Okay. So then the area of the triangles, of course, to this one, we could use any angle we want, but since we first finding the angle C, then why don't we use the angle C to help us to finish the problem then? So it will be 1/2. If we work with the angle C, then we need to use the adjacent side, which is 5 and 6. 5 times 6. And then sine of 92.8660. Okay. Then you will get 14.9812. Okay. So then in this case, okay, to this problem, the angle A equal to 38.6248. Angle B equal to 48.5092. And angle C equal to 92.8660. Okay. And the total area is equal to 14.9812 then. Okay. Okay, so now then let us work on the problem number 6. Okay. Now number 6 would like to find the shaded area bounded by triangles and part of the circle with the radius of 8. Okay. So then to this one, in order to find the shaded area, what we can do is we can find again the area of the triangle first, and then we subtract the area of the sector, right? Okay. So in this case, then we know that to this one, this is 8, this is 12, this is 6. And to this sector right here, we have 8. Okay. So then we know that if I want to find the area of the triangles, if I know that this angle right here, okay, is theta, okay, then it is equal to 1/2 8 times 12 times sine of the angle theta. And then minus, okay, now in chapter 5, we have learned how to find the area of the sector already, which is 1/2 theta r squared. Okay. Of course, to this angle theta, we know that it must be in radian. Okay. So how do we actually, again, work it out this problem? So basically, when we try to use a calculator to find the angle, we just need to set the angle in radian mole instead of degree mole. Then we will be able to find the angle in radian then. Okay, so the first step is we would like to find the angle theta. Remember, it must be in radian. Then we have the opposite 6 and the angle theta. So we could set it up 6 squared equal to x squared plus 12 squared minus 2 times 8 times 12 times cosine of theta. Okay. And then if I want to solve for cosine of theta, then it will be 6 squared minus x squared minus 12 squared divided by negative 2 times 8 times 12. And of course, theta will be the cosine inverse of the expression. Now, let us go to the calculator now, okay? So, okay. So first, you would like to check the mole, okay? Make sure that you set it to degree mole first, okay? And then now I will have cosine inverse of 6 squared minus 8 squared minus 12 squared cosine divided by negative 2 times 8 times 12. Okay, so then now I get the angle is 0.4604934.251. Okay. And now we can find the area now. Okay. So the area is equal to 1/2 8 times 12 times sine of the angle minus 1/2 the angle times 8 squared then. Okay. Okay. So then we could have, again, 1/2 is 0.5. So I have 0.5 times 8 times 12 times sine of the answer that I have, and minus 0.5 times the angle times x squared. Okay. Then my answer will be 6.5949406. Okay. Okay. So again, if the problem asks you to round it to 4 decimal places, or how, again, whatever they ask you then. And now, the next topic I would like to introduce is the bearing in negation system then. Okay. In negation system, A direction is often given as a bearing. This is what we want to learn. That is, has an acute angle measured from due north or due south. Okay. So for example, if we have the angle, okay, from due north is 30 degrees, then of course this one is between north and east, right? So in bearing, we just say that is north 30 degree east. Okay. Okay. Again, if we have the direction is again, is again 60 degree in between the directions and the north here, then so this is between north and west. So it will be north 60 degree west. Okay. So in this case right here, okay, we measure the angle from due south is 70 degree. It will be south 7 degree west. And of course, this one will be south 50 degree east then. Okay. So now what if I have the directions? Okay. In this case, I say that, oh, here I actually have 7 degree. Okay. And of course, this is north right here, right? So in this case, how do I actually, again, name the directions now? Okay. So in this case, I cannot use this 70 degree right away. What I need to measure is I always measure from due north, right? So then this is a 20 degree here. So that's why this will be the north 20 degree east then. Similarly, if I have, again, the direction is this way here, okay, this is the directions. Then if this is like 50 degree here, then I know that from due south, this angle right here, it will be 40 degree, okay? So then my answer will be south 40 degree west, okay? So this is, again, how we have the direction in bearing now. Okay. Now, from time to time, if we have the angle, okay, is exactly 45 degree, okay, then of course we could say that this one is north 45 degree east, but usually we are not saying this way, we just say that it's northeast, okay. And again, if this is 45 degree here, then it will be northwest, southwest, southeast, okay. Okay, so now then let us look at our last example, okay. When I try to work out this type of problem, what I will do first, I would like to sketch the diagram, okay, of this first, and then try to see how we use maybe law of sine or cosine to help us to finish the problem then, okay. Then in this case, let's think about this. I have an airplane fired north 20 degree west, okay, so consider that we started this point, and then the plane that we have is starting this way, okay, and then from city A to B, and then with the direction 150, and then 100 miles, okay, to northeast, north 50 degrees, okay. So okay, then let's see. I would like to sketch a better graph now, okay. So we start with the city A. Is that here, okay. And then now we are going to find northwest, okay. And remember this angle right here is 20 degree, okay. To the city B, Okay. And then from here, we find again northeast, right? So we will have north 50 degree is, okay. Then for another 100 miles. Okay. And then we get to the city C then. Okay. Then now, let's see what they ask you to do. I would like to know that how far this is directly from city A to city C. Okay. So therefore, in this case, what we are looking for, we actually be looking for the distance between city A and city C. So we would like to find this distance right here. Okay. And now we know that this side is 100 miles, this one is 150. If I know this angle, maybe I call this angle theta now. If I know this angle theta, then I will be able to find the angle D. That means I will be able to find the length D then, okay, using law of cosine. And what information do I know, okay, to find the angle theta? First, I know that this is 50 degree. And now, if this one right here, if this is 20 degree here, that means this angle right here, it must be 20 degree. And I know that this angle here is also 20 degree. So therefore, in this case, of course, I know that theta, it will be 180 degree minus 50 degree minus 20 degree. So it is equal to 110. Okay. Then now, based on this, then we could actually find D. Okay, is we will have D square equal to 150 square plus 100 square minus 2 times 150, 100, and cosine of 110, right? Then, of course, D will be the square root of this whole thing here. And remember, when you work with your calculator, make sure that it is in degree mode, right? And now the answer is 206.7863736 miles. Okay. So then now I actually answer A. And then now let us look at what B. I would like to know what bearing should the pilots use to fly directly from city A to city C. Okay. So, and now let's check it out. Okay. So to this one, then from city A to city C, okay, we know the distance, or maybe we know that this line right here is actually is D. Okay. So what I need to find is I need to find this angle. Maybe I call this angle theta. And then how is this angle beta relate to the problem? Okay. So maybe let me extend a little bit. So this is the angle beta that we have. Then now, if I could find this angle, okay, maybe I call this angle alpha now. Okay. If I could find the angle alpha, then now the angle beta will be alpha minus 20, isn't it? Okay. Okay, so then let's see how we actually work out this problem now. So I would like to find the angle alpha. So I have sine of alpha divided by 100 equal to sine of 110 divided by 206.78633736. And now the angle alpha will be the sine inverse of 100 times sine of 110 divided by 206.8736 now. And now your calculator will tell you that alpha is equal to 27.0281 degree. Then now I would like to find the angle beta, which is 27.0281 minus 20 degree, which is 7.0281 degree. So the pilot is to find in this direction north, 7.0281 degree is there. Okay. Now, of course, what if the angle alpha is less than, again, 20 degree? Then now you will see that basically the pilot will find in northwest, okay, this angle. Okay. Okay, so thank you.